The first question. The first terms of an arithmetic sequence are: find x if the sum of the first 20 terms of the sequence is equal to 100. There are many ways how to solve this problem, but I would like to flip each term using the next formula. It is also given in data booklet that log AB is equal to log CB over log CA, where C it may be absolutely any value. So if you consider C to be equal to B, you get that log AB is equal to 1 over log BA. So our sequence becomes log x2, log x8, log x32, and so on. But 8 it's 2 cubed, 32 is 2 to the power of 5, and using another property, a formula, we can rewrite that it becomes log x2, 3 log x2, 5 log x2, and so on. And to get equation to find x, we can consider the sum of the first 20 terms. Formula is also given in data booklet. Sum of 20 terms is equal to n over 2, it's 10. 2u1, the first term is this 1, so it's 2 times log x2 plus n minus 1, so it's 19, times common difference. Difference is any minus the previous, so it is equal to 2 log x2, and it is equal to 100. So 2 log plus 19 log, it is equal to 40 log x2, it is equal to 10 log x2 is 1 over 4, and x to the power of 1 over 4 is equal to 2. Raise both sides by to the power of 4 and get answer that x is 16. And that's all for this question. The next question, in an arithmetic sequence, the first term is 8 and the common difference is 1 over 4. If the sum of the first two n terms is equal to the sum of the next n terms, find n. First of all, how can we write, for example, the 10th term in using sum? The 10th term, it is equal to the sum of the first 10 terms minus sum of the first 9 terms. And if we consider, for example, the first two n terms, for example, from 1 up to 20, it's 2 n terms. So the next n terms are terms from 21 and up to term at position 30, and hence the next n terms can be written as sum of 3n terms minus sum of the first 2n terms. So the sum of the first 2n terms is equal to the sum of the next n terms. So it's sum of 3n minus sum of 2n. So move this sum of 2n to the left to get 2 sum of 2n terms is equal to sum of 3n terms. And using formula for the sum of n terms is n over 2. 2u1 plus n minus 1 times the difference, and sum of 2n terms becomes, we just substitute 2n for n and get 2 multiplied by 2n over 2. You can cancel 2. And 2 times u1 is 16 plus n minus 1 becomes 2n minus 1, and common difference is 1 over 4, so it's over 4, and it should be equal to sum of the first 3 n terms, so substitute 3n for n and get 3n over 2, 16 plus 3n minus 1 over 4, and we can also cancel n, and finally we get a linear equation with respect to n, which can be easily solved, and the final answer is 63. And that's all for this question. The next question: find the sum of all 3-digit natural numbers that are not exactly divisible by 3. Numbers which are not divisible by 3, it will be more useful to find a sum of all numbers, 3-digit numbers. The first number is 100 and the last is 999, and minus divisible by 3. So let's consider sum of all 3-digit numbers. u1 is 100, un is 999, and if you are not sure how many terms are there, what is the value of n, you can consider just basic equations that un is 999 and it is equal to u1 100 plus n minus 1 d. Difference is 1 because there are consecutive numbers, so just 1. So 899 is equal to n minus 1, so n is 900. For such problems, it would be better to check because you can easily make mistake. So sum over 900 is equal to 900 over 2, u1 plus un, so it's 100 plus 990 and 99. And now let's consider sum of numbers which are divisible by 3. The first possible number which is divisible by 3 is 102, and the last one, again it's un, we don't know its number, is 999. And again, to find n, we can write that un 999 is equal to u1 plus n minus 1 n times common difference, but here the next number is previous plus 3, so common difference is 3. So n is 897 over 3 plus 1. It is equal to n, and it is equal to 300. So sum of numbers which are divisible by 3, it's sum of 300 terms, and it is equal to, use formula n over 2 u1 multiplied by u1 plus un, so it becomes 300 over 2. The first term is 102 plus the last term it's 999, and hence required sum is equal to sum of all numbers minus sum of numbers which are divisible by 3, sum of 300 according to our notation. And if you calculate it, the answer is this value. And that's all for this question.